In this lesson, we will learn about algebraic identities. Algebraic identities are very useful in factorizing polynomials. So let's start with the first identity, the basic one which you have learned in the previous classes, that is x plus y whole square is equal to x square plus 2xy plus y square. So we can prove the above identity graphically. Consider the big square blue of side x plus y and a small square in the pink which is of side x. So the area of the bigger square is x plus y square because the area of a square is side square. The side over here is x plus y. So the area of the bigger square is x plus y whole square. So if you observe closely, the bigger square is made up of three boxes. The one in the pink, the one in the green, and the one in the orange. So if you add the areas of all these three boxes, you will end up with the area of the overall square. So let's look at the pink one. So this is a square of side x. So we know that the area of a square is side square, and side over here is x. So x square. So that's the first box. The second box on the top is a rectangle whose height is y and whose width is x. So the length is x and the breadth is y. And we know that the area of the rectangle is length times breadth. So that will end up with xy. And finally, we have to calculate the area of the box in the orange. And again, this is a rectangle whose length is y and the height is x plus y, which is the side of the bigger square. So we end up with x plus y times y. So if you simplify this, you will get x square plus xy plus x times y is xy plus y times y is y square. So this is nothing but x square plus 2xy plus y square. So this is how you can prove this above identity, x plus y whole square equal to x square plus 2xy plus y square. Now let's look at few more identities. The next identity that we will look at is x minus y whole square is equal to x square minus 2xy plus y square. You can again prove this graphically just like the previous identity that I have explained. The third one that we will look at is x plus y times x minus y is equal to x square minus y square. Again, you have learned this in your previous classes. The next identity that we look at is x plus a times x plus b equal to x square plus a plus b times x plus ab. So if you observe closely, we have actually discussed this in a previous lesson of factorizing a quadratic polynomial. Right hand side is a quadratic polynomial and the left hand side we have expressed it as a product of two polynomials. And we know that we can express a quadratic polynomial as a product of two other polynomials only when the coefficient of the x term is the sum of those two numbers a and b, and the constant term is the product of those two numbers a and b. So this identity is exactly stating what we have learned previously. If you are given x square minus 25 and you are asked to factorize this polynomial, so you observe this is in the form of x square minus 5 square, and you know from the identity 3 that x square minus y square is x plus y, which is x plus 5 times x minus 5. So this is how you can factorize that polynomial. Similarly, if you are given x square plus 5x plus 6 and you are asked to factorize this, this is a quadratic polynomial. Find two numbers whose product is 6 and whose sum is 5. So if you factorize 6, you get 2 and 3. So sum of these two is 5 and product of these two numbers is 6. So we can express this as x plus 2 times x plus 3. So in this way you can apply identities and factorize polynomials very easily. The next identity that we look at is x plus y plus z whole square is equal to x square plus y square plus z square plus 2xy plus 2yz plus 2xz. Let's try to prove this. Let's express x plus y as one term and z as another term. So if this is in the form of a plus b whole square, and we know that a plus b whole square is a square plus 2ab plus b square. So applying that formula, we will get x plus y whole square plus 2 times x plus y times z plus z square. So if you expand this, x plus y whole square again we know is in the form of a plus b whole square. So that will be x square plus 2xy plus y square, and then you multiply z with x and y in the second term. So you'll end up with 2xz plus 2yz plus z square. So if we rearrange terms, this is in the form of x square plus y square plus z square plus 2xy plus 2yz plus 2xz. So in this way, you can prove this above identity. The next identity that we will work on is x plus y whole cube is equal to x cube plus y cube plus 3xy times x plus y. Now let's try to prove this. So this can be expressed as x plus y whole square times x plus y. So that is nothing but x plus y whole cube. So the first term is in the form of a plus b whole square. So this is x square plus 2xy plus y square, and then we are multiplying that with x plus y. Now let's try to expand this. Multiply x with the first term. So you'll get x cube plus 2x square y plus xy square. Now multiply y with the first term. You will get x square y plus 2xy square plus y cube. So rearranging terms, you will end up with x cube plus y cube plus 3x square y plus 3x y square. So that's nothing but x cube plus y cube plus, taking 3xy common, you will get x plus y, which is your RHS. Next identity we learn is x minus y whole cube is equal to x cube minus y cube minus 3xy times x minus y. And prove this exactly similar to the one which we have learned before. So expressing the left hand side as x minus y whole square times x minus y. X minus y whole square, as we know, is in the form of a minus b whole square is x square minus 2xy plus y square. Multiply that with x minus y. And expanding on this, you will get x cube minus 2x square y plus xy square minus x square y plus 2xy square minus y cube. And rearranging terms, you will get x cube minus y cube minus 3x square y plus 3xy square. And finally, by taking minus 3xy common, you will get x cube minus y cube minus 3xy times x minus y. So in this way, you can prove this above identity. The next identity we'll talk about is x plus y plus z times x square plus y square plus z square minus xy minus yz minus xz is equal to x cube plus y cube plus z cube minus 3xyz. So this is simple. You just multiply the two terms on the left hand side and simplify it, and you should end up multiplying the two terms. You will end up with this very big algebraic, and you can simplify this. Xy square and xy square gets cancelled out. Xz square and xz square gets cancelled out. Minus x square y gets cancelled out. Minus x square z and x square z gets cancelled out. Similarly, yz square and yz square gets cancelled out, and y square z gets cancelled out. So you will remain with x cube plus y cube plus z cube, and there are 3 xyz terms. So minus 3xyz. So that's your R. So let's look at an example. If you're asked to calculate the product of a plus b plus 2c times a square plus b square plus 4c square minus ab minus 2bc minus 2ac. If you observe closely, this is in the form of x plus y plus z times x square plus y square plus z square minus xy minus yz minus xz. And we know that this is equal to x cube plus y cube plus z cube minus 3xyz. Here x equal to a, y equal to b, and z equal to 2c. So you will end up with a cube plus b cube plus 2c whole cube minus 3 times a, b and 2c. So that is equal to a cube plus b cube plus 8c cube minus 6abc. So in this way, you can apply the identity and calculate the product of these two polynomials very easily.